So today, I want to talk to you about how it is that we can do research of a scientific kind for something as complex as human behavior, as opposed to things that are simple, like nuclear physics or quantum physics or chemical analysis or biological exploration through a microscope. People are simply more complex than pretty much anything I can think of, and to do research on them, to understand how a human mind works, how a brain works, how society functions, and how relationships function, is complex and a challenging story. And the story of clever Hans just goes to demonstrate that an animal is very complicated. So just imagine how complicated people are. So the usual thing is to run an experiment. You have a group of participants that volunteer and agree to the ethical codes that scientists must abide by, and then we can draw some conclusions based upon the experiments that those participants engage in. And there's a lot of dramatic stories. There's case studies. There's single case studies, just like clever Hans, and there's a lot of big discoveries that have taken place in various ways. And we'll really explore a lot of that within this course, but I want to just start off with a hypothesis. And from there we can have an educated guess. And hypothesis is essentially just an educated guess. And we try to make a decision. So I'm going to talk to you today about research in psychology. And the funny thing about psychology, and I'll come back to that, is that everybody really wants to be an amateur psychologist. Everybody wants to be an observer of people. And we live in a world where there's people like Dr. Phil and radio hosts and all sorts of people that use the fact that most people don't understand people to make themselves appear more intelligent. And the fact is, even psychologists are not mind readers. But we do experiments in order to discover the likelihood of certain things occurring. Now, here's a kind of sentence from a publication that just drives psychologists crazy. Almost half of children of divorces enter adulthood as worried, underachieving, self-deprecating, and sometimes angry young men and women. And that sounds like a psychological study of some kind, right? That somebody wants to argue about the importance of divorce and breakdown of the family. But just think about that for a moment. Almost half of children of divorce enter adulthood are worried. Well, worried about what? Worried about crime in their community, worried about whether or not they're going to have a job after they graduate from college, worried about their debt, worried about who they're going to find a relationship, worried about foreign wars, worried about the economy, worried about COVID-19, worried about whatever's in your head. People are worried. So the fact is that statement doesn't tell you anything that really connects worry and divorce. And so it's very misleading. And so it's very important for us to ensure that we always look at statements with a very critical eye. Now, here's another thing. It says they're underachieving. Well, underachieving compared to what? To what someone says without any evidence? The statement that somebody can prove that someone is underachieving. How do you do that scientifically? It's just a statement. In order to move the emotion along at the mythic level. Self-deprecating? Well, sometimes it's actually nice for a person to be modest. It's not necessarily a bad thing sometimes to be modest, to be self-deprecating on occasion, especially if it's inaccurate. Now, perspectives of yourself that are pathological self-deprecation, well, that's a completely different story. But the headline doesn't say anything about that. And they're angry men and women. Well, have you been angry in the last year? Societies break down, relationships break down, there's disappointments in life, we get frustrated. It doesn't mean that that's a cause, something that was caused by divorce. Even when there's a correlation, that does not mean that one thing causes another. So we need to look at statements, question them, ask, what does this mean? We need to look at the statement, see if it's accurate. We need to look at what is the answer and what is the question. It's like that issue of clever Hans. Was Hans clever? Yes, he was very smart. But could he read German? No. Could he do math? No. So that's the thing that I want you to be mindful of. And the same thing can be true when we make statements about people. Things that we say we know to be true, 99% of the time, we only know it because someone who is in authority tells us that. But as good critical consumers of knowledge and of research, we should analyze things. And that is part of the reason why research in psychology is so important. Just because our parents tell us something doesn't make something true. Just because our teachers tell us something doesn't necessarily make it true. Just because we read it in a textbook doesn't necessarily make it true. We need to always look behind the statement of truth and see whether or not it is correct. And so the role of science, in particular the scientific study of psychology, is a continually refining to hold on to what holds up to the evidence and let fall away what does not hold up to the evidence. So there are things like repetition and tenacity. You hear something often enough and people tend to believe it. Now, is that reasonable? No. But it's how people work. And so we need to be mindful that we need to follow things rationally. We need to follow knowledge based upon the evidence. So, one of the ways we can do that is through scientific analysis, where we have a hypothesis, an educated guess about how something works. And we test that hypothesis with various experiments. And we see where the numbers lead us. What we're always trying to do in quantitative experiments is to disprove the null hypothesis, the negative statement of the hypothesis statistically. And in psychology, it's next to impossible to prove something is true. And so what we do is we try to prove something is probably untrue or likely untrue, statistically likely untrue. And in so doing, then we can, as a standard of practice, accept the alternative hypothesis, an alternative explanation. But then again, in the long run, we then need to conduct more experiments to test that alternative hypothesis and refine it even more. And so it's a continual process that we go through. So, within this, we are trying to disprove the null hypothesis and accept the alternative hypothesis with the statistical quantitative experimental research in psychology. So what makes something an experiment? Well, you need to start off with two things conceptually. First is the dependent variable, what you measure as the outcome, and the independent variable, what you vary. And once you have those two things in an experiment, you're ready to go. You kind of are on your way to having an experiment, at least in the broad sense of the word. So in psychology, it took a long time to figure out this sort of thing, and it wasn't until the 1800s that people had really kind of developed a reasonably good way of doing experiments and beginning to figure things out. For example, how to use simple measurement of time to measure how long it takes for a mental operation to last in your mind. That's a pretty good start. And with that, we had Wilhelm Wundt, who we talked about in the last lecture. And one of the big figures in the experimental psychology is that Wilhelm Wundt, he set up that laboratory in Leipzig, Germany. And he did tests on mental chronometry. And what he simply did was measure how long it takes to do something. And then you can see, okay, it takes 1/5 of a second to flip a switch, or it takes 1/10 of a second to decide whether or not a light is red or green and push a button. So his idea was that there's a motor system to push the button, and then there's also the time it takes for a person to distinguish between different stimuli and to process that. When you subtract the one time from the other, and you get a sense of how long it takes for an objective sense mental operation to process in your mind. And that was a huge step. And then psychology went in a different direction with people like Tickner, who worked with the psychology department at Cornell University. And he was interested in introspection and looking at inside yourself to think very carefully. And when you think about a topic, how do you think about it? And then he was interested in how can we turn that and use a scientific experiment in some way to make that testable. Because these introspective processes are private processes. How can we externalize that in some way? And so there was some effort to quantify experimental science. And so as we moved into the early part of the 20th century, we moved and tried to move away from this loosey-goosey introspection into something that was much more concrete. And that's where we get a fellow by the name of John B. Watson, who was known as the father of behaviorism. And what he said is that the mind is unobservable, and so you cannot use that as a method for studying. You need to look at behavior. What is measurable? Things are only real if they are measurable. And so in looking at that, then there was another transformation in this process. And then there's the whole question of correlation. Correlation between people asking questions. And one of the things that people will often come up with is, we have A and we have B, and they vary in similar ways, so the one must cause the other. Well, that's not necessarily the case. In order for one to cause the other, there has to be a time-order relationship. A has to always happen before B, and there needs to be this one-to-one correlation. And we need to rule out other variables as well, other possible explanations. And so correlation does not denote causation. And that's another important thing to be mindful of, and why experiments are needed to establish a time-order relationship, to eliminate other causal factors, so that you can clearly delineate that A does actually cause B. The cause and the effect need to have a clear relationship. It's like this, for example. 100% of people that are in jail for murder eat bread. Therefore, bread causes murder. Well, obviously that's wrong. There are lots of other factors that we could look at, and when you start to parse things out, you see that eating bread is just an extraneous variable, although a very common one. So there are lots of cases that you can come to mind and that you can be mindful of when you are looking at research and trying to clarify the reality that correlation does not equal causation. So let's take a look at experiments here. So as a psychology student, you are really wanting to understand the basics of a psychological experiment and what kind of goes into it. So in the overall context of research methods, there are 3 types of psychological research in truth. Yes, there may be more or less, but just to keep it simple, right now, I want to kind of classify it into 3 major ways. The first is causal or experimental research. So here we're going to look at what causes something, and that's our ultimate goal. When people think of scientific experimentation, research on cause and effect is most often what comes to mind, and experiments on causal relationships investigate the effect of one or more variables on one or more outcome variables. And this type of research also determines if one variable causes another variable to change or occur over time. An example of this type of research would be the changing the amount of a specific treatment and measuring the effect on the study participants. So a simple experiment is research is often used to determine if changes in one variable might lead to the change of another variable. In other words, to establish this cause and effect. And in a simple experiment, looking at the effectiveness, for example, of a new medication, for instance, where you study participants, and these participants would be randomly assigned to one of 2 groups, and one of these elements, or one of these groups, would be the control group and receive no treatment, while the other group would be the experimental group and they would receive the treatment being studied. So there's some basic elements that you need to consider within a simple experiment. A simple experiment really is composed of several key elements. You have the experimental hypothesis. So this is the statement that predicts that the treatment will cause an effect, and so will always be phrased as a cause-effect statement. So, for example, researchers might phrase a hypothesis this way. Giving someone an experimental treatment will have no effect. Experimental treatment A will result in a reduction of symptoms in disorder B. Okay, so we have that. That would be our experimental hypothesis. Then there is the null hypothesis, and remember, it's hard to prove something, so we try to disprove something. And so this is the hypothesis that the experimental treatment will have no effect on the participants or dependent variables. And it's important to note that failing to not find an effect of a treatment does not mean that there is no effect. The treatment might impact other variables that the researcher is not measuring in the current experiment. So there's always needs to be that kind of openness within an experiment. As you look at things, then there are the response. And there needs to be, within this independent variable, we need to look at what's going on with that variable and how it's manipulated by the experimenter. And then, of course, we need to have the dependent variable, and that refers to the response of the independent variable. And the researchers are measuring the dependent variable. And as I've already mentioned, you'll need the control group, and these are the individuals who are randomly assigned to a group, but do not receive treatment. And the measurements taken from the control group will be compared to those of the experimental group to determine if the treatment had an effect. And that, of course, brings us to determine the results of the experiment. And once the data from a simple experiment are gathered, researchers will compare the results of the experiment to those of the control group to determine if the treatment had an effect. Now, there can always be the possibility of errors. It's not possible to be 100% sure of the relationship between any two variables. There might be an unknown variable that is playing an influence on the outcomes of the experiment, just like with clever hands. And so we need to be mindful that despite this challenge, there may always be something else that's playing a meaningful relationship. And so in this, though, we can trust in the statistics and draw some reasonable inferences about a population based upon measurements taken from a representative sample of that population. And the key here is determining if a treatment had an effect to a measure that is statistically significant. And statistical significance shows that the relationship between the variables is probably not due to mere chance. So we try to say, for example, statistically significant level of less than 5% chance of this occurring by chance. That's the kind of thing that we're doing in an experiment. Now, we're going to take a little break and come back and look at other approaches other than experiments, other ways that we can find doing research in psychology. And I hope you continue to enjoy this class.